I've mentioned that science advances by taking measurements, and in this video we're going to talk about the proper way to take a measurement. I call this the one more decimal place rule. One more decimal place. Or the OMDP, and if you put little dots by all the words, it helps you remember that DP stands for a decimal place. And this is a very important rule because you don't want to put more into your measurement than is there. You also don't want to take out anything that is there. You want to make a nice, precise measurement. But the thing of it is, your measurement is only as precise as the tool that you're using. Measuring devices have tick marks that enable you to take a reading. A proper reading will give you one more decimal place beyond the tick mark, and that's all the more precision that you can expect. So let's use this example. I have here a little bit of a metric ruler. It's each of the ones that are marked, the 10, 11, and 12, are marking centimeters. So that means that the tick marks themselves are measuring millimeters. There should be 10 in between. Let's see, from 11 to 12 we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Indeed, the tick marks are measuring 1 millimeter. This is the precision that you can get from using this measuring tool. And the rule says that we can get one more decimal place. So we can get 1 point something millimeters out of this ruler. Now, how do we do that? Well, we need something to measure, and since this ruler is so poorly drawn, I'm just going to have it stop somewhere between 10 and 11 centimeters. There's the thing we're measuring, and we look down at it, and it's more than 10.6 centimeters, but it's less than 10.7 centimeters. So we have a problem. In this case, the time-honored rule is to divide the space between the tick marks. That would be the space between this tick mark and this tick mark mentally into 10. And then just pick the closest one that you think. I'm going to draw a little thin line that I hope is at the end of this thing we're measuring and comes down there. And oh dear, it looks like it's just about exactly halfway between, which is not what I wanted to use as an example, but we'll use it since that's what happened. So it's about halfway between. So what we're going to be doing is adding 1/2 of a millimeter, or 0.5 of a millimeter, to our measurement. But our ruler is actually graduated in centimeters, and so it would be most natural to give the measurement in centimeters. And we look at it and we see we've got 10. No, Sugarfoot, what's going on? We have 10.6 centimeters plus a little more, and so we're going to get 10.65 centimeters. Now you have to remember, a millimeter is 1/10 of a centimeter, so half a millimeter is 0.05 of a centimeter. And so we have indeed gotten one more decimal place, because the tick mark would give us 10.6 or 10.7, but we have decided that our measurement is 10.65. It's one more decimal place. Now this rule holds even if your measurement comes right smack dab exactly to a tick mark. And let me show you what this is going to look like. Okay, now we have a measurement that, to the best of my ability, is in line with the 10.5 tick mark on this ruler. But the rule of taking a measurement says that you can get one more decimal place. Well, how do we do that? Because we don't have anything going in between. We have 10.5. The way we do it is it's a 0. There's 0 going on between this line and the next tick mark because it stops right at the 10.5 mark. So no matter whether your measurement stops in between or whether your measurement stops right at a tick mark, you want to have one more decimal place. The way to get one more decimal place when it stops at a tick mark is to add a 0, as you should. And the way to get one more decimal place if it stops in between is to mentally divide it in 10 and then decide how many of those tenths it's extending through, and using that to figure out what your new measurement should be. Okay, this is getting a little long, but let's do one with a graduated cylinder. My graduated cylinder, the way I've drawn it, is not too plausible because you see that 0 sticking way up there, and let me put some units on here. Milliliters. You see that 0 milliliters is kind of sticking up there where you would expect there to be some, there is already some volume, so it's not 0. But anyway, this is for example. What we're trying to do is read this and decide how to determine the next decimal place. So what decimal places do you have already? Well, you see that between the tick marks that are marked, the 0, the 10, and the 20 milliliter tick marks, you have 1, 2, 3, 4. So you have 2, 4, 6, 8, 10. So each tick mark, in this case, now one tick mark is equal to 2 milliliters. And that's what we need to work with. Remember that when you use a graduated cylinder, you measure from the bottom of the meniscus. The blue line right there is the meniscus. So far we have 10, 12, 14. So far we have 14 milliliters in the graduated cylinder. But the reading goes not quite to 16, not quite to 15. I'm going to draw a little line, and I'm afraid that once again I have drawn myself right at the 0.5 mark, but let's see. Well, it might be a little bit curvy, but I wouldn't call that the 0.5 mark at all. I would call that 0.2. It's 0.2 tenths of the way between 2 milliliters. So what does that mean? Well, think about it. 1/10 of the way would be 0.2 milliliters. 2/10 of the way, and you just multiply by whatever the tick is worth, you get 0.4 milliliters. And so we have a reading of 14 milliliters plus 0.4 milliliters. And so our final reading for this meniscus is 14.4 milliliters. Do you see how you've gotten one more decimal place? There it is. Okay? Your thing is only graduated to 2. 2, and 2 would be in the ones place. But we have a reading now that's down to the tenths place. And that's what I mean by one more decimal place. Let's do one more example. Here we have a scale that was obviously drawn by a first grader, and they have put the tick marks around it that are extremely regular, and there's exactly the same amount of space between these tick marks. Just use your imagination. And they're marked every 10 pounds. Marked every 10 pounds. So in this case, one tick mark is equal to 5 pounds, because between the tick marks that are marked, you have one more. So the distance between the tick marks would be this distance, and that would be 5 pounds. So we're measuring some random tennis balls or some kind of brown fruit. And we see that we're at 20, 25. We're at least 25 pounds, but we're not quite to 30. And if I eyeball that, I would say we're plus 0.4 of the distance between the 25 and the 30. Well, we want to do 0.4 times 5 pounds, because that's what each tick mark represents. So we have 25 pounds. Oh, sugarfoot. Anyway, pounds plus 0.4 times 5 would be 2 pounds. 2 pounds equals 2.0 pounds equals 27.0 pounds. And you see these are marked down to exactly to the ones place, and we can have a reading down to tenths place. Let me just show you why I seem to have randomly stuck that in so that I could make this agree with what I'm saying in this video. When you do your 0.4 times your 5 pounds product multiplication, 4 5s are 20, and then you move the decimal point. And so that is the number that you want to be adding in to the 25. So you're adding 25 plus 2.0, and there it is, 2.0. I've used the L in pounds to draw my circle, to get a final reading on the scale of 27.0 pounds. And so that is the one more decimal place rule. That's how it works. And remember, you got to have units. So find out what those tick marks represent. Use your mental calibration techniques to divide between tick marks, and don't give yourself any more precision, but don't lose any precision either. All right, see you in the next video.